Hello everyone. Today we are going to discuss yet another example of assignment model. As you all know, there are four special cases in assignment problem, and the example that we are going to discuss is of special case number 2, that is maximization. Here, the given example is find the assignment problem or assignment of salesmen to various district which will yield maximum profit. Now, the first and foremost thing is where most of the students make mistake is how to find out that this problem is of special case, that is maximization. So, a simple technique is whenever there is a word maximum or maximization or something which is related to profit, it means that this particular example is of maximization. Here the matrix given is there are four district 1, 2, 3 and 4, and salesmen are there A, B, C and D, and we have to assign these salesmen to the district such that profit is maximum. Hence, the first step of maximization or the solution first step is, first of all, we have to convert this minimization matrix to maximization. As the problem is of maximization, hence we have to convert this minimization matrix to maximization. Now, the first step for conversion of minimization matrix to maximization is, first of all, you have to select an element from this matrix which is having a highest value. As we can see, there are 16 elements in this particular matrix and highest element is 16. Now, in order to convert this minimization matrix to maximization, we have to subtract all the elements of this matrix from this highest element 16. Once again, I'm repeating, in order to convert this minimization matrix to maximization, first of all, we have to select the maximum element, that is 16 in this given matrix, subtract all other values of this matrix from 16. So, 16 minus 16, 0, 16 minus 10, 6, 16 minus 14, 2, 16 minus 11, 5. Similarly, we have to select all other values. We have to subtract, all other values from 16. So 16 minus 14, 2. 16 minus 11, 5. 16 minus 15, 1. 16 minus 15, 1. 16 minus 15 is again 1. Similarly for row C and row D. And this matrix that we have got is called as a maximization matrix. Now, once we have got this maximization matrix, now we can apply the steps of Hungarian method. So, the first step of Hungarian method is row subtraction. Now, this is the maximization matrix that we have got after applying the steps of maximization. So, row subtraction step we are going to apply on this new matrix, that is maximization matrix. So, as per row subtraction, as you all are aware, row subtraction is nothing but from the first row we have to select the smallest element, and that smallest element we have to subtract from all other elements of that row only. So, in row A, smallest element is 0. So, in row subtraction, we have to subtract this 0 from all other elements of that row only. So, 0 minus 0, 0, 6 minus 0, 6, 2 minus 0, 2, and 5 minus 0 is 5. Similarly, for row number B, lowest element is 1. So, subtract this lowest element from all other elements of that row only. 2 minus 1, 1, 5 minus 1, 4, 1 minus 1 is 0, and 1 minus 1 is 0. Similarly, for row number C, lowest element is 1. Subtract this 1 from all other elements of that row. 1 minus 1, 0, 1 minus 1, 0, 3 minus 1 is 2, and 4 minus 3 is 3. Similarly, apply the same method or same technique for row number D. So, after subtracting the smallest element, that is 1, from all other elements of row D, we'll get the values 2, 3, 1 and 0. So, this is the matrix that we have got after row subtraction. Now, after row subtraction, next step is column subtraction. The techniques that we have applied for row subtraction, that is row wise, similarly same kind of subtraction technique we are going to do column wise. So here are 4 columns, 1, 2, 3 and 4. From the column number 1, lowest element is 0. So subtract this 0 from all other elements of this column. As we are doing column subtraction, hence select the smallest element from column number 1 and subtract all other elements from this particular column. So 0 minus 0, 0, 1 minus 0, 1, 0 minus 0, 0, 2 minus 0 is 2. Similarly, for column number 2, lowest element is again 0. Hence, 6 minus 0, 6. 4 minus 0, 4. 0 minus 0, 0. 3 minus 0 is 3. Similarly, for column number 3, lowest element is 0. Hence, all other values of this column will remain as it is. Because when we subtract 0 from any value, that value will remain as it is. For column number 4, again lowest element is 0. Subtract this 0 from all other elements of this particular column. 5 minus 0, 5. 0 minus 0, 0. 3 minus 0, 3. 0 minus 0 is 0. So this is the matrix that we have got after column subtraction. As we are done with column subtraction, next step, as you all know, is draw lines. So for drawing the lines as per the rule. Now what is the rule for drawing the lines? For drawing the lines, the first and foremost thing is we have to count for number of zeros row wise as well as column wise. So row A, number of zeros 1, row B, number of zeros 2, row C, number of zeros 2, row D, number of zeros 1. Similarly, we will count for number of zeros column wise. First column, number of zeros 2, second column, number of zeros 1, third column, number of zeros 1, and fourth column, number of zeros 2. As per the criteria or the rule, we can draw a line either row wise or column wise. The only thing is we have to cover maximum number of zeros. Here you can see maximum number of zeros are in row B and row C. Similarly, maximum number of zeros, that is 2 zeros, are there in column 1 and column 4. So I have 4 options available here. I can draw 2 horizontal lines or 2 vertical lines. So it's up to the student. Either you can draw a horizontal line or a vertical line. Only make sure that your first line will cover maximum zeros. So I'm drawing this line on row B because in row B there are 2 zeros. So this is my line number 1. Similarly, row C, I'm drawing a line because again this line will cover 2 zeros. This is my line number 2. Now, the only zero left is first row, first column, and last row, last column. So only 1 zero is remaining. So in order to cover this particular zero, I am going to draw line number 3 and this will be my line number 4. As you can see here, I have drawn 1, 2, 3 and 4 lines in order to cover all the zeros. And as per the rule, if number of lines drawn is equal to number of rows and columns, hence we can go for making the assignment. As this matrix is a balanced matrix which contains 4 rows and 4 columns, and the number of lines that we have drawn are also 4, hence we can go for drawing the lines. As in this previous step, we have seen that we have drawn 1, 2, 3 and 4 lines in order to cover all the zeros. Hence, number of lines is equal to number of rows and columns. Number of rows are A, B, C and D. Number of columns are 1, 2, 3 and 4. That means there are 4 rows and 4 columns and we have drawn 4 lines. Hence, now we can go for making the assignment. Now, how to do the assignment? As we all know, the criteria for doing the assignment is we have to do the assignment either row wise or column wise. The only thing is we have to see for a row which contains only 1 zero. Now row A contains only 1 zero, row B 2 zeros, row C 2 zeros and row D 1 zero. So we'll start doing assignment with row A because this row contains only 1 zero. Now as this row contains only 1 zero, this is my assignment number 1. The 0 which is my assignment, I am doing a square mark. Now this 0 in which I have done the assignment, that is square mark, this 0 is in column number 1. From that particular column, we have to cross mark all the zeros. Once again, I'll repeat this step. We are doing assignment row wise. We have selected row A because it contains only one zero. So I have done a square mark to this particular zero. This zero is in column number 1. Hence, cancel out all other zeros from that particular column. Again, repeat the same process. Row B, there are two zeros. So leave that row. Now row C, there is only one zero. Previously, there were two zeros, but one zero we have cancelled out. So for now, there is only one zero. So this is my assignment number 2. Again, repeat the same process. Now row D, again there is only one zero, and as per the criteria we can make the assignment from a row which contains only one zero. So there is only one zero, so this is my assignment number 3. Now this 0 is in column number 4, hence cancel out all other zeros from that particular column. So I have cancelled out this 0. Again repeating the same process. Row A, no 0 is left. Now row B, there is 1 0, and this is my final assignment. As there is only one 0 in this particular row, so I have square marked this particular 0, and these are my 4 assignments. So after doing the assignment, last step is we have to allocate these salesmen to the district. As we can see, the square mark is nothing but the assignment. So salesman A is assigned to district 1. Salesman B is assigned to district 3. Salesman C is assigned to district 2. And salesman D is assigned to district 4. So these are my assignments. A is assigned to 1, B is assigned to 0, C is assigned to 2, and D is assigned to 4. Now the last step is how to do the final, or how to find out the final value. From the question, as we can see in the question we have seen, so this is the given question. In the question we have seen, what we have seen, A1 value is 16. So I am writing here 16. B3, from the question, B3 value is 15. C2 value is again 15, and D4 value is again 15. So total comes up to 61. So this is the final answer of this maximization problem. I have assigned and I have written the values which are given in the question. So A1 is 16, B3 is 15, C2 is 15, and D4 is 15. So 15 for the 60 plus 1, that is 61.